Hello, everyone. Can you guys in the back hear me okay? Perfect. So my name is Christine, and this is,
Ellen.
yes, and today we're talking about TypeScript. Yay. So what is TypeScript? Oh, okay. Oh, and before we start, we have another word from our sponsor, Moby. But this is, just in case you missed Ben's wonderful talk. But as you probably already know, Moby builds technologies that expand the human ability to navigate the world. Moby's core ability is to model decision making through a planning platform to solve complex problems for the individual and at scale that the human brain can't solve alone. Moby's AI planning platform integrates robust datasets capable of fleet efficiency optimization, business process automation, as well as guiding travelers to the tastiest meals and off the beaten path experiences worldwide, as we saw in Ben's talk. Moby's ability to solve tough problems at scale is being used by the world's largest brands. It was founded in the research labs of MIT in 2012, and they worked, built, and learned together at their headquarters in Somerville, Massachusetts. They're proud to be backed by an outstanding group of investors, Firefly Venture Partners, RMP Ventures, and Enterprise Holdings, who share their commitment to building transformative travel technologies. Okay. So now we've talked about how Moby helps us see the world. Now let's see how JavaScript sees the world as well. So it does it with data types. And in particular, primitive data types are the most basic or fundamental objects in a language. You may have seen this in other programming languages you may have come across, such as Python. Yes, and all other types are constructed from them. And if we're talking chemistry, these primitive data types will be our elements. So yes, these are the primitive data types: number, Boolean, string, object, undefined, and null. And we also have their examples, which you've probably seen through the lectures we've done so far and workshops. So for number, for Boolean, true or false, string, yes, and so on and so forth. You may have noticed that when we've been working in JavaScript so far, we don't specify types. Why? Well, this is because JavaScript is dynamically typed. You may be wondering, what does this mean? This means that types are only associated with values, so a variable's type can change during execution. And because it changes, we don't bother to check types when compiling, and instead we only check at runtime. And this allows us to program a lot faster. So as you can see in the example above, 5 is at first a number, then it becomes a string, then it becomes undefined. But how do we make sure that 5 always remains a number? Well, sadly, JavaScript cannot do this. But lucky for us, TypeScript can. So if you look here, we specify that we want 5 to be a number. And so when we try to change to something else, undefined, we then get a wonderful error. And we cannot continue until we fix it. So dynamics typing is really flexible. So you're not able to detect some errors until runtime. But even though static typing is a lot slower and stricter, and it takes a while before you can be sure everything works in the right place, and you're sure what you have is completely correct, and you will run into issues later down the road. So we've sort of hinted about types in TypeScript, but what is it? So TypeScript is built on top of JavaScript, and it enforces a static typing. And it also has a lot of other features as well. And it checks that your code works at compile time, which will definitely save your life when debugging. In fact, it said that 15% of the errors that you find in JavaScript at runtime can be caught by TypeScript while the compiler is running. So JavaScript has no static type checking. So when you write code, you sort of hope in VS Code it works and everything is fine. But TypeScript is different. When you write code, static type checking happens as you're writing, and then when you finish, it's compiled into JavaScript. So how do you make types? How do you use types? Well, you can use the calling notation to specify the type you want, which in this case is a string, or you can just assign a variable to any value, which in our case is hello, a string. So that way, it knows that X, Y, and Z should all be strings, and then when you try to reassign it to a number, for example, we get a wonderful error. Okay, So why do we care about static typing? Like why TypeScript? Like we've been hanging out with JavaScript all this while and we like it. Why should we switch? Well, this is because these are the examples of issues that static typing can catch. One is missing or unnecessary prop values. So in this example, you see profile props. The only property we have is user ID. But if we, by mistake, we ask for the password, which doesn't exist, we get a wonderful error and we don't have to wait till runtime to catch it. The next error we're able to catch is similarly named variables or functions. But of course, please don't do this in your projects. So if we have the example of call string and call string is a function, but called string is a string. And we want to assign new string to be called string, but we make a mistake. We put call string by accident. Well, it knows that this is incorrect because it knows call string is a function and not what we're expecting. So we're able to catch it, the compiler is able to catch it, and we don't have to wait to runtime. The next problem it's able to catch is undefined or null behavior, which is also known as the billion-dollar mistake by its creator. Why? Well, this is because with null values, even they technically hold no value. So when you try to call some operations on it, it throws a mistake. But what TypeScript allows you to do is that you can avoid null values completely by specifying that you want a variable to be a string alone. But if you say you want to create a union of types, such as a string and a null, then that way you're able to handle null checking by yourself. And then the last error it's able to catch is overloaded operators. So you probably saw this in the JavaScript lecture, typecasting. So if, let's say we add a string to a number, it converts that number to a string as well, and then it adds the two by concatenating them. But that's not what we expect, right? Especially if 5 was originally supposed to be a number. We're expecting a number in return. But thankfully, our compiler is able to catch this mistake before we hit production. So these problems might seem obvious because we looked at smaller examples, but when you're working with your projects, you'll be working with a lot of lines of code, and checking all of them is pretty exhausting. So this is why we love TypeScript, and we hope we've convinced you to love TypeScript as well. So for more on TypeScript, we'll move on to Helen. But before that, does anyone have any questions? Everyone good? Can I get thumbs up? Perfect.
Okay, so now that you've heard some of the basics on like what TypeScript is and why you might want to switch to TypeScript, let's go over some more specifics or details on how to write TypeScript code. So remember, we have like three main primitive types, which are string, boolean, and number. So when you declare variables in TypeScript, you can explicitly define the type that the variable is. So the syntax for doing this, as shown at the top, is you can use let or const as usual, and then the name of the variable, here it's message, followed by a colon and the type of the variable. So here we're assigning the variable named message to specifically be of type string, and we're assigning it to hello world. This way, the TypeScript compiler can check if you try to reassign message to a value that's not a type string, then the TypeScript compiler is going to complain. So here's the error that you might see, which is type number is not assignable to type string. And so even though we initially used let, meaning that we should be able to reassign this variable, you cannot reassign a variable of a type in TypeScript to a value of a different type. And while this might seem to make TypeScript less flexible than JavaScript or Python, where you can do this, doing this is actually, like reassigning variables to different types is actually pretty bad practice. It might lead to weird errors later on where, like, let's say someone else is writing code and they didn't realize that message got reassigned to a different type. Then you might end up with weird errors later on. So keeping your types consistent is generally good coding style and will help keep your code type safe. All right. Oh, another small thing is that while in this example, in the red box, I used a colon syntax for colon string, you actually don't need that here because the TypeScript compiler can automatically detect that hello world is a string. So you don't need to explicitly say that message is of type string because it's really obvious that it's of type string. So it's generally good practice to not include repetitive information when you're coding. So because it's already really obvious that the variable message is a string, you actually shouldn't explicitly say it here. But I did it here just for illustrative purposes. But if you didn't include this colon string, your code would also work perfectly fine. All right, so some more types that you should be familiar with are arrays and enums. So an array is very similar to how it works in JavaScript, except to assign a variable to type array, you also need to specify what the type of the elements in the array are. And there's two ways you can do this. At the top, you can do it type followed by brackets, or you can do array enclosing the type. But you should specify what the type is within your array if it's not already obvious. So in these two examples, we're restricting the variable message to be specifically an array with elements that are only strings. So you cannot have any other types within the array. If you, however, want to make your array have multiple types within them, then you can use this OR operator. So in the bottom example here, you can see that we're assigning the variable example to be an array of both strings and numbers. And this is how you could have an array with multiple types. Okay, so for enums are an important feature in TypeScript. Basically, they allow you to impose more specific restrictions on types. So here in the example, we have the color type, which is specifically the strings red or green or blue. And this provides a more specific restriction than just a string type. So if we wanted to make a variable C of type color, C can only be blue, green, or red. It cannot be any other string. So if you have a variable that can only be a specific set of values, then you should use enums to enforce this restriction. Another nice thing about TypeScript is that you can define your own types. And so here we're defining the type user, and a user logically has some properties associated with it. A user has an ID, a name, and whether or not they're an admin. And each of these properties has a type that they have to be. So the ID has to be a string, the name has to be a string, its admin has to be a Boolean. And using these types is really helpful for making your code type safe, because anytime you use the user type, this enforces that you have to declare the properties ID and name here. So let's say we wanted to create an object of type user, then we have to specify the ID and name. Note, however, that we did not specify isAdmin when we created the user variable. And this is because isAdmin has a special question mark when we defined it in the type. This means that isAdmin is actually an optional property. So because isAdmin has a question mark next to it, you don't actually have to set isAdmin to anything when you create a user object. Great. And the nice thing about custom types is that you can also nest them within each other, just like with your primitive types. So on the left here, we created a user type, and we also create message and chat data custom types. So for the message type, we can see how we can use our custom type user as the type for one of our properties. And then for chat data, we can use the custom message type that we also defined previously. And you can also put your custom type objects into arrays. So on the right here, we have defined the user type and created two user variables of that type that we defined. And then we can then put these user and user2 variables into an array of type array user. So you can do a lot with your custom types, and I highly recommend making custom types if you end up using TypeScript, because it'll make your code a lot more modular, easy to read, and type safe. Okay, another cool syntax thing that you can do in TypeScript is actually extend types. So on the left here is the same code logic as what's on the right. On the left, you can see we're making two types, user and user login. So for user, we have an ID, name, and isAdmin. For user login, we have ID, name, isAdmin, and password. But you can see that we have three repeating lines between the two. And in general, when you're coding, it is bad practice to have a lot of repetitive things. So if you're copy and pasting large sections of code, you're probably doing something bad. So here's a less repetitive way to write what's on the left. So instead of copying the three lines, ID, name, and isAdmin between our two types, we can use type extension. So if you use this ampersand syntax, we can attach the user type to another property password string and assign it to the user login type. So this is the same thing as writing out user login, like in line 7 to 12 on the left, but it's a much more concise way to write it. All right, so another important note about TypeScript is that when you write your functions, you should declare the type for the function parameters and the function output. This way, users know exactly what type gets passed into a function and what type comes out. And you can imagine this makes it easier both as a developer writing your code and also as someone reading or using the functions you write. So as a developer, if you can strictly enforce exactly what type gets passed into your function, then you can help like prevent a lot of edge cases or like unknown behavior that could happen. And as someone reading the functions you write or using the functions you write, it's very clear then exactly what's passed into the function and what you get out of the function. So at the top here, we have a version of the function getComments, and this is written in JavaScript. And getComments is a function that takes in an ID and then returns an empty array. So this JavaScript version is a little bit mysterious because you don't actually know what the type of ID is. ID could be a string or a number or even a custom type, but you don't know. And you don't actually know what it returns either. So it's a little bit unclear exactly what this function is supposed to do. So at the bottom here, we have the TypeScript version of getComments. In the TypeScript version, it's a lot clearer what's going on because it's obvious that ID, the parameter you're passing in, is of type string. So you know exactly that you have to you have to pass in a string into this function. And also getComments returns an array of comments. And so TypeScript makes your functions a lot more type safe and a lot easier to read. So you can also use built-in React events as well with your type functions. So for example, in this handle change function, we pass in an event that is a react.change event type. And there's a lot of these that you can look up on Google and in the React documentation, but just note that if you're using React with TypeScript, you also want to use React types. And recall we also have asynchronous functions. So with asynchronous functions, we have the keyword async and we return promises. And we need to specify this in our types as well. So at the top, we have our JavaScript version, which again is a little bit mysterious because we know that it's a getComments function that takes in an ID and is asynchronous. But again, we don't know exactly what ID is or what it returns. So if we write this in TypeScript, we get what's on the bottom, which is an asynchronous function that takes in an ID that we know is specifically a string and returns a promise that resolves into a list of comments. So with asynchronous functions, when you have a promise return type, you can use the promise keyword, and you also want to enclose within your promise keyword exactly the type that the promise resolves into. Okay, so just like in JavaScript and TypeScript, we have first-class functions. So functions in TypeScript are treated just like any other variable, so you can add them as a property to your custom types. So in our type comment props here, we have our regular properties, ID, creator name, and content of type string, but we can also add a function as a property of our type. So here, handle add is actually a function, and what this function does is you also need to specify the type of its parameters and output. So there's nothing here in these parentheses, meaning that it doesn't take in any parameters and it doesn't return anything. So here the output is of type void. Okay, so since we just worked with Chatbook, let's look at a Chatbook example in TypeScript. So the nice thing about TypeScript is that you can have typed props and states. So for our props, we can define a custom type for our props, and we can also define the types of the properties under that prop. So if we have our profile function here that takes in our props, then we know exactly that the props are of type profile props, and we know exactly what properties are under this prop. And again, the same thing with state. You can define the exact type for your state variable. So because initially user is undefined, we need to tell TypeScript eventually what user will become once the state changes. So that's why we included the type user or undefined here. For cat happiness, which is initially 0, we didn't need to explicitly define the type here because it's already obvious to the TypeScript compiler that cat happiness is of type number. Okay, so let's look at another chatbook example. You can actually export to reuse your custom types in other files. So here we define our custom types user, message, and chat data and exported them. And then you can import them to use your custom types in a different file. So this makes your types nicely reusable throughout your code base. And it helps modularize and make your code more type safe. All right, so I just went over a lot of stuff about TypeScript syntax. The nice thing about TypeScript is that it's really easy to integrate into your projects. So it works really well with defining React and prop state types, as we just saw. And you can actually integrate TypeScript slowly or partially into your projects. And you don't need to write entirely in JavaScript or entirely in TypeScript. And this is because TypeScript is a superset of JavaScript. This means that any valid JavaScript code is also valid TypeScript code. So even if you've already started your project in JavaScript, you can very easily switch to TypeScript. So this Twitter post says, my toxic trait is setting up TypeScript in a project and then just writing JavaScript. And basically this means that a lot of developers, they aim to use TypeScript because it's I think better coding standards, but sometimes they get lazy and don't define all their types. And then it just ends up becoming JavaScript. But you shouldn't do that. You should make your code type safe with TypeScript. Okay, so if you want to integrate TypeScript into your project, there's instructions on this link. We also provide a TypeScript skeleton for you. So in addition to the JavaScript skeleton, there's a TypeScript skeleton. So you can start your project in TypeScript, which I recommend. But if you end up starting in JavaScript, you can very easily switch to TypeScript. Okay, so now I'm just going to show you really quickly Catbook, but in TypeScript. So if you want to see this, you can go to the Catbook React workshop. You don't have to follow along now, but there's a link in the slides if you want to look at it. But basically, if you go to the branches and search up TypeScript functional, this is a version of Catbook, but in TypeScript, if you want to get an idea of what the code looks like. So I cloned this repo, and here is the code side by side. I don't know if you can see it. Okay, so on the left here, we have JavaScript, and on the right, we have TypeScript. And the code is very similar. There's just a few differences in how we define our types, but it's really easy to convert from JavaScript to TypeScript. So ignore the white space here. I just wanted to align the functional parts of this code. But basically in TypeScript, you can see we define a type for our props. And again, this enforces that our props have to have these properties. So we know exactly what properties we can access in our props. But this part, the function definition, is basically the same, except we have to specify the type for our props, which is the custom type that we just defined. And our hook use state is the same because, again, it's clear to the TypeScript compiler that the initial type for value is a string. So we don't need to explicitly define this. And as also with our handle change and handle submit functions, the only difference really is that we're explicitly saying that the event is of type react.change event or react.mouse event. But everything else is basically the same. So it's very easy to move from JavaScript to TypeScript. You just need to define your types. And you can also create custom types, which is really nice. So yeah, we highly recommend using TypeScript if you can. It'll make your code a lot safer and easier to read. Yeah. Okay. So back to this. If you want to play around with TypeScript, we linked a TypeScript playground in the slides. Basically, this lets you just play around with writing TypeScript code if you want to do some practice with it. Yeah, here's a resource, web lab TypeScript skeleton. So if you want to get started with TypeScript, then you can use the skeleton here. And yeah, we recommend using TypeScript again because it's type safe. And I also, in my experience, it's, at least in my internships, it's used more in industry. And also it's used in 6031, which is an MIT course that most 6.3s have to take. So if you want to practice with TypeScript, now is a good time to start. And that's all. All right, any questions? All right.